So chapter 15, we're still using our same time value of money keys, and we're still using our financial calculator to solve these problems as well. We do not use the tables, we do not use the formulas, we use our financial calculators. Now this chapter, we add the concept of an annuity. An annuity is a steady stream of payments. So your key words there are, it's going to be, they make a payment at the end of every year, at the end of every month, at the end of every quarter. Anytime they're making that steady stream of payments, that same amount on a repeating basis, that's your clue that we're using the payment key. So again, we still have our same keys of our calculator, and they still mean the same thing, but now this is our steady stream of payments. And again, that key word is at the end of every. So if you see that, then you know for sure you're dealing with a payment. Everything else is still the same. This is still our number of compounding periods. This is still our rate per period. This is our present value or today's value. And then this is our future value. But just like we had in chapter 14, we're going to be computing for one of these values, and one of them is going to be a 0. So when I enter on whatever button I'm not using, I always push a 0 in there so I know that that's not going to factor into my computation. So again, make sure you're very comfortable with the values that go in there, and as you read the problems, you can fill those in. So for our first example, we have a basic IRA. We have at the end of each quarter, the Rodriguez family invests $450. So at the end of every quarter, they're depositing $450 into an IRA. So that $450 becomes the payment. They are earning 8% compounded quarterly, so find the amount of their annuity at the end of 3.5 years. So find the amount of that annuity tells us we're computing the future value of that steady stream of payments. So that's what we're computing. And our N is going to be the 3.5 years, but then we're dealing with quarterly payments, quarterly compounding. So we need to take our 3.5 and multiply that by the 4 quarters. So we're going to have 14 quarters in that period. Our rate, they tell us that they're earning in this IRA is 8%. But again, that's 8% a year. We want to put it in as a quarterly amount, so it's 8 divided by 4, so that's going to be 2. They're earning 2% each quarter. Now, so in this one, it doesn't say that they have anything to put down today. Nowhere in that problem did it tell us that they have an amount today, so we're going to zero that out. But they're investing $450 at the end of each quarter. So if we put those into our calculator, same way we did it in chapter 14, so you push the 14 and then push your N button, the 2 and then you push your IY button, 0, your present value, 450 is your PMT or your payment, and then now hit compute, and then your future value. So after 3.5 years of saving, they would have $7,188.27 in their IRA. Okay, then we can have ones where, like the lottery is a good example of it, where we're going to receive an amount every year, and we're trying to bring that back to a present value. Retirement is another good example. If you know, okay, gosh, when I retire, I think I'm going to need to withdraw so much money out of my retirement account. How much do I need to have the day I retire? So you're taking future payments and bringing them back to a present value. This one, we were taking payments and saving, and we're going to say how much would we have at the end. We're saving for something. if it's payments that are coming out, we can bring those back to a present value to say how much do we need to have. So then that's what this example does. So it says, Wee Long was elated that she had won the lottery, paying $85,480 at the end of each year for 20 years. So find the amount that the state must set aside today to satisfy this annuity at 8% compounded annually. So your key words there, though, are find the amount that they must set aside today, so then you know you're computing for that present value. It tells us that they're going to receive this amount for 20 years. So it's an annual amount, so we don't have to worry about it compounding. So it's just 20 years. Their annuity, it tells us, is at 8%, so that's our IY. The amount that Wee Long is going to get paid every year is $85,480. And there's no future value. Nowhere in the problem does it tell us that after she gets paid $85,480, at the end of 20 years, she's going to get another $1 million. She's not. She's done after those 20 years. So we'll zero out that future value. So we'll come to our calculator, put in 20, push our N button, 8, the IY button. We're computing for the present value, so we can skip over that. 85,480. Push your PMT button for your payment. 0, that future value. And then come back and hit compute. And then push your present value button. So $839,255.24. So that is how much the lottery would have to set aside the day that she won so that they would legally have the money to pay her. That money would be set aside from the rest of their earnings, and that would be earmarked for this particular winner. And then every year, $85,480 would come out of that amount, and at the end of 20 years, it would be 0. So that is the goal for that. And retirement is another good example. Anytime you see a retirement problem, it's going to be the same thing. What they want to withdraw at the time that they retire becomes the payment, and we're going to compute the present value to say how much do they need to have the day they retire to get to that amount. Then you could maybe have a two-step problem where then you go back further in time to say, well, if I have 20 years to save, then that what I just computed as the present value becomes my future value. It becomes my goal, and then I save to that. So a good example of that one is if we have, in addition to his income from Social Security and 2 rental houses, Chandra needs $18,000 at the end of each year for 25 years at retirement. So how much must he accumulate if he's earning 7% a year? So he wants to be able to withdraw $18,000 at the end of each year. So that $18,000 at the end of each year indicates a payment. He thinks he's going to be retired for 25 years before he would die. He's earning 7% on his investments. And then there's no future value in here because this is funding his retirement. It doesn't say that he wants to have a certain amount when he dies. He can use every last penny of that. So when we're dealing with retirement and we're taking those payments and bringing them back to a present value, there is no future value. So if we put this into our calculator, we've got 25 as our N, 7 as our IY. We're going to compute the present value so we can skip over that. 18,000 is our PMT or our payment with no future value. He can take every last penny out of that account. And then come back, hit your compute button, hit your present value button. This Chandra would need $209,764.49 the day he retires. Now this problem ends there, but if I add a second part to it and I say, okay, say he has 20 years to save. or 20 years to retirement. Then I can do a second part to say, okay, now if he's got 20 years to save and he's earning 7% on his investments, he's starting with nothing today, how much would he have to set aside every year to have his savings goal? So then now this becomes a future value because he's not in retirement right now. He's got 20 years to get there. So this first step just helped him determine what is my goal. Then step 2 actually gives you the objectives to reach that goal. So how much do I need to save each year so that I can retire and have $209,764? So then in this case, we're filling in the new years because now we've got 20 years that we can save. Our IY is still 7. We're not starting with anything today, but we want to end up with $209,764.49. So that is my future value. Then I come back and hit compute and my payment. So he would need to start saving about $5,000 a year in his retirement so he could have his goal. He could have his $209,764. So this is one that sometimes students struggle with, but it's one that you'll find on your test and I think on your time value of money project. So use this as an example on how to compute those. Okay, then we also get into sinking funds. And sinking funds, we're still using our same time value of money keys. But then now it's dealing with businesses or cities, people who maybe issue bonds. A lot of times with those bonds, the city or the company has to set money aside so that they have the ability to pay those bonds off when they come due. So we have an example of a city sold $4 million worth of bonds to pay for a new jail. To pay off those bonds when they mature in 8 years, the city sets up a sinking fund. So basically in that sinking fund, they're going to set money aside that is earmarked specifically to pay those bonds off, so they can't use it for anything else. So find the amount of each payment into the fund if the city makes annual payments and the money earns 6% compounded annually. So then, now in this case, we're not computing for our present value, we're computing for our payment. So our key words there was it said find the amount they need to set aside annually. So that indicates to us it's a payment that we're looking for. Their bonds, it tells us, are 8-year bonds, so they have to pay them off in 8 years. Compounds annually, so that makes it a little bit easier. They are earning 6% annually, so that's our IY. We don't have anything in today's value. They're not setting any money aside today, but what they need to have in the future is $4 million. That's how much the bonds are, that's how much they owe, and that's how much they have to be able to pay. So how much should they set aside each year so they can get there? So again, coming back to our calculator, 8, push the N button, 6, push the IY button, 0 out the present value because they've got nothing today. We're going to compute the payment, so we skip over that. $4 million is our future value, so push the FV button, then push compute and PMT. And they would need to be setting aside $404,143.77. So then that's how much money they would need to be setting aside each year so that they would end up with their $4 million to pay back those bondholders. So then that is kind of an example of different calculations within Chapter 15. So look over my additional in-class exercises that are worked out in a Word document, and then get busy on your My Math Lab homework.